Well, hello, my students. Pretty much the remaining of the year is going to be from the fundamental counting theorem. Woo-hoo. And you're going to need a calculator eventually. Today you don't. I made the numbers real small, but eventually we're going to need a calculator, like tomorrow. Now, our test is going to be Friday. It's going to be graphing in degrees, graphing in radians, finding trig functions of radians, like the sine of pi, and you must show your work. You don't show your work, it's a 0. Let me say that one more time. If you don't show your work, it's 0. And I'm not going to do anything new Friday. Friday, the video will just be the test. That's for my 7th and 8th graders. And, it'll be on Schoology for my high school kids. So nothing new on Friday, so you can focus on the test. It's going to be the last big grade. Now, we'll have some quizzes, of course. But the fundamental counting theorem says this. So Friday's the test. Okay, so the fundamental counting theorem says this. If set A has A items, and if set B has B items, oops, I didn't write down, sorry, B items, then the number of groups that can be made taking one item from each is A times B. Now, set A and set B have to be unique. Now, set just means a group of items. So that just means if I want to take form groups, and I take the boys softball team and the girls, I said that wrong, the boys baseball team and the girls softball team, I'd be okay because there's no boys playing softball, no girls playing baseball. But if I said girls soccer and I want to compare that with the girls class, I couldn't do it because there's some girls that are playing soccer. So it has to be unique. So if I said I'm a new coach, let's say, and I coach freshman girls soccer, and let's say it's 20 girls on the team. And what I've decided to do is over the summer, I'm going to pair every freshman girls soccer with a senior girl cross country. And the idea is for them to work together so they both can focus on running, because soccer has a lot of running in it. And let's say I have 30 different senior girls cross-country players. So how many different groups of 2 could be made? Well, the fundamental counting theorem says, hey, this is one group of unique items from this. There's no senior girls playing freshman soccer, or if there is, they got problems. Should cancel the season, I guess. So the number of different two-people groups, one from each, would be 20 times 30, which is 600. That's the fundamental counting theorem. If you have unique, you just multiply the number of items from each. So, if I said a car can have, let's not do car, I'm tired of that. Let's do a meal can have one meat, must have a meat, can't have a vegetarian to have this meal, I guess. One meat, one veg, and one dessert. And let's say I go to a restaurant and they have 10 meats choices. They have 2 vegetables, corn and potatoes. That's the only vegetables out there. And let's say they have 20 types of dessert. Because a real restaurant should have more desserts than any other items. How many different meals could be produced taking one from each? So you would go, wait a minute, fundamental counting theorem says if I'm taking one from each set and a vegetable can't be a meat and meat can't be vegetable. Now I know they make meat from vegetables now, pretend meat, but not real meat. So you would go 2 times 20 is 40, times 10 is 400 different meals. So they could do advertisements. Say, hey, you could go a whole year, come in every day and still not have the same meal because there's 400 different meals. Now you might have the same meat. You'd have to have the same meat. So let's say the freshman boys next year, let's say there's, I have no idea. Let's say there's 100 freshman boys, and let's say freshman girls, there's, let's say 20. Now there's more, there's about 120 of each. From what I understand, our enrollment hasn't gone down any. In fact, the grade school's gone up, so good. But how many different groups of 2? So we're having a dance. And before we leave, each freshman boy must dance with each freshman girl, or each freshman girl has to dance. I don't know why I didn't put boy there. Has to dance with each freshman boy. Okay? So how many different dances would have to occur? 20 times 100. 2,000 different dances. Now, let's say I own 4 books. Let's say, of course, I have Bible. I have the first Harry Potter. I have, let's say, math for jocks. And let's say I have Star Trek. Now, I'm having my girlfriend over. How many different ways could I put these books in a row to make me look the smartest? Well, I have 4 different slots. Now, in the first spot, I could put 4 different books. But notice, the second spot, one of the books is now gone because it's in the first spot. Now, 2 of the books are gone. Now, 1 of the book is left. So, fundamental counting theorem, you multiply 4 times 3 is 12, times 2 is 24. So there's 24 ways I could put 4 books. This has actually got a mathematical symbol. It's called a factorial. It's an exclamation point. So you'd write this 4 factorial. That means multiply by the number. It's n and n minus 1 all the way down to 1. So if I said I have 7 people lined up to go to lunch, how many different ways could 7 people line up? Well, one way of doing this is to make 7 spots and say first spot 7, 6, 5, 4, 3, 2, and then the last spot only has 1 choice. Or as soon as I say how many ways can 7 people line up, It's 7 factorial. Now, there's a factorial button on your calculator, and I can't find it. Here we go. 7 times 6 times 5 times 4 times 3 times 2. Now, here's what I find incredible. 7 factorial is actually 5,040 different ways. Now, we'll do some more of this tomorrow, but you have another assignment due tomorrow. It's this one. Graph that and do those problems. Dupe and then dupe. So how many ways could 6 people stand in a row? Lunch. 6 students. Second hour. So Friday I'll put the answer guide out to this because this is due tomorrow night. Okay, good, my honors. I'll put this on Schoology, by the way. Have a good day.